Okay, in this video, I'm going to introduce some things that you're going to need to know how to do in KNES 300 in some software called Microsoft Excel, which some of you might be pretty familiar with, but some people also come into this class not having any familiarity with this software. So anything that you can do before getting into that class to familiarize yourself with using software like Microsoft Excel will be a benefit to you once you get into it. And it's not just for KNES 300 either. You'll use software like Microsoft Excel a lot in other classes in the KNES major or other classes at UMD in general, depending on which classes you're taking. It's software generally for working with numbers and making graphs and figures and things like that. And so it's necessary for KNES 300. You'll use it a lot there, but it'll also be something you'll have to use probably in other classes that you'll take in your career here at UMD. If you're not familiar with Microsoft Excel, it is, if I go down to my dock here, it is this green program here with the X. It is software for doing operations with what are called spreadsheets in the business world. It's basically tables of data, columns and rows of numbers. Typically for when we are using it in a class like KNES 300, it'll be data from experiments that you'll collect or be given data for lab exercises, and you will be doing some calculations on those data and making graphs of the results that you get from those calculations to include in your lab reports in that class. So it's general software for what would typically be classified in science as scientific computing for working with numbers and doing calculations with numbers, implementing equations to calculate things using those numbers and making graphs to present your results from those calculations. If you don't have Microsoft Excel, you can obtain it and lots of other cool software by going to this website here, terpware.umd.edu. Here, UMD has lots of kind of campus-wide subscriptions to lots of different types of software that's normally like really expensive software. Like this, some of these things would be many thousands of dollars if you wanted to go out and like buy your own personal copy of these software. UMD has some subscriptions and some deals worked out to enable students to download and use a lot of that software for free, for no cost to you if you go to Terpware here and just browse over what they have available there for software. Again, many of you might know about this already, but if you don't, this is a good resource that you can use here on campus while you're a student. For example, if you get a new computer and you want to put Microsoft Excel on it, you can go here to Terpware and you can click on Office Tools. And here you can install Microsoft Office, which includes Microsoft Excel and Microsoft Word and PowerPoint and some other elements of that suite of Office software, all that you can download and install and use on your computer for free. And but not just Excel and Office. There's lots of different software over here in these different categories. That's really nice, really expensive software that you can access for free as a student here. So make sure you check that out and take a look at that if you're not already familiar with Terpware. But that's where you might go to get software like Microsoft Excel if you don't have it already on your computer and you need to use it for a class. There's also other spreadsheet software available. I'm a Mac user, so some of the instructions that I give here might be unique to the Mac version, but if you're using like a Windows machine, the way that you use Excel on Windows should be pretty similar to how it is on a Mac. There might be some subtle differences, but the general operations that you'll do and the functions that you'll use will be pretty similar between Mac and Windows. There's also Numbers, which is kind of Apple's version of Excel, their spreadsheet. I don't think it's very good. I wouldn't use it unless you have to. You probably want to use Excel if you can. Google has their online thing, which is Google Sheets. It's the Google Docs version of spreadsheet software. I don't know much about it. It seems to be kind of functionally kind of similar to Excel. So you don't have to necessarily use Excel for these things. You can do similar things in other software like Numbers and Google Sheets. But I very much recommend using Excel if you're able to use Excel. It's kind of the industry standard for doing this type of stuff, and especially if you want to like get assistance from your professors or on your TAs, they're gonna in most cases be much more familiar with Excel and much more able to help you out with Excel than if you're using something else like Google Sheets or like Numbers. Okay, so what do we do in Excel? In KNES 300, you're going to use Excel to perform calculations, and you're going to use it to implement like equations from class to calculate numbers from other numbers, and you're going to use it to then make plots to display those calculations that you'll then include in lab reports and things like that. So let's see some examples of things that you might need to be able to do in Excel to be successful in a class like KNES 300. One of the biggest things you'll have to do is learn how to take a mathematical equation from like a textbook or a paper or like a slide in class, transcribe that equation into Excel and use it to actually perform calculations with that equation in practice on real data, on real numbers. So actually doing like the grunt work and like the guts of biomechanics, actually performing the calculations, not just reading about like, oh, this equation describes this and that, actually taking that equation and using it in practice to calculate a biomechanical quantity. So let's see a quick example of that, of the type of thing that you'll do in KNES 300 that involves Excel, and the type of things in Excel that you'll need to be familiar with and be able to do to be successful in this part of KNES 300. So one particular problem that you get in KNES 300 that involves using Microsoft Excel is calculating segment angles. Segment angles, mechanically, are like the posture of a part of your body relative to the room you're standing in. And so like this dashed line here that I have labeled theta trunk on this figure, that's the segment angle of the trunk. The trunk is a part of the body or a segment of the body. And so it's the angle of your trunk relative to the room here, relative to like the floor, to the right horizontal. And you can also see that here for other parts of the body, like the angle of the thigh relative to the room or relative to the right horizontal here, angle of the shank, angle of the foot, etc. And so mechanically, that's what I mean by segment angles. It's like the orientation of a part of my body relative to the room that I'm standing in. We will calculate those quantities in KNES 300. On their own, they're not all that interesting, but if you know like the angles of like two body segments, like you know the angle of my upper arm and the angle of my forearm, the difference between those two gives you the angle of my elbow, which is a mechanically interesting and a kinesiologically interesting variable in a lot of cases. For example, if you know the angle of the elbow and the speed at which the angle of the elbow is changing, this can tell you something about what the muscles that span the elbow are doing, like what the triceps are doing and what the biceps are doing. And that's often something of interest to us in biomechanics. We'll often want to take measurements of like whole body human movement and from that infer what's happening inside the body where we can't measure things. Like what are the muscles doing? What are the forces in the muscles? What are the strains on the muscle fibers and the tendons and things of that nature? All things that we can get some educated guesses at and some model-based estimates of if we do this type of modeling, this type of biomechanical analysis of things like segment angles and joint angles. So calculating segment angles, and then from those segment angles, calculating joint angles. What does that look like exactly? Well, let's take a look at a more specific example. And so this is a problem that the students in class in KNES 300 just did here, where if I give you the coordinates of the three main joints of the lower leg, so I tell you where is the hip, where is the knee, and where is the ankle, from there, can you calculate the angle of the knee joint or the amount of flexion that the knee joint has when these three joints here are in this position? And so what this is saying here is like for the hip, it says it's at 0 and 98 centimeters, 0, 98. The knee is at 9.5 and 45, and the ankle is at 3.9, 3.5 centimeters. That's saying like picture on this 2D plane that you guys are looking at here, picture like a vertical y-axis and like a horizontal x-axis there. And so each of those pairs of numbers that I had on that slide to describe those joints, that hip and that knee and that ankle, that's telling you like where in this coordinate system here those three joints are located. So where in this kind of flat plane on your screen here, where is the hip, where is the knee, and where is the ankle? So like the X, Y coordinates of those joints if somebody was like walking across the screen like that. If my finger waving and using my arms to represent coordinate systems isn't entirely clear to you, I drew what's hopefully a better picture here, where those data that I had on that slide, if you were to plot them out and graph them and then draw a stick figure there connecting them, representing like a real human leg, would look something like this. So the hip is at a certain coordinate, a certain distance from the x-axis and a certain distance from the y-axis, the knee, and then the ankle. So just coordinate points representing like where in space are these major joints of the body, the hip and the knee and the ankle. We can measure those coordinates pretty easily by like sticking reflective markers on somebody's body and having them walk around in our motion capture space, and then we can get numbers describing like where was that part of the body while this person was moving. So an example of the type of data that we collect in biomechanics. We then want to take those data, those marker coordinates, so x, y positions of these joints, and use them to calculate a variable that's of more kinesiological interest, that I can use my terms from anatomy and physiology to describe the motion of the body, and that's something like the angle of the knee joint here. Okay. So how do I take these coordinates here, these x, y coordinates, and transform them from these xy coordinates here to this flexion angle of this knee joint here, the angle of the lower leg there relative to the upper leg? Well, how do I do that exactly? First, I need to calculate the angle of the upper leg here, the thigh, relative to the room. And then I need to calculate the angle of the shank here, the angle of the lower leg relative to the room. Okay? I can then take the difference between those two segment angles, subtract, for example, the shank angle from the thigh angle, and that's going to give me the knee angle. Okay, don't worry right now about the theory and the mechanics behind all that and why that's the case necessarily. Those are the things that we introduce in KNES 300. But here I'm just going to show you an example of the type of calculation that you do in KNES 300 and how to do it in Excel, and like the skills and experiences you need with Excel to kind of hit the ground running in 300 and be successful in it. So how would we actually do these calculations in a piece of software like Excel? Well, first, we're going to want to take these data that I gave you, and we're going to want to transcribe them from this slide telling you these data into Excel where I can use those data. So let's pop open Excel here. And I've got another example up here I'm going to show you some stuff in later, so let's just make a blank screen here in Excel. And let's zoom in a bit here so you guys can see this a little better, hopefully. Okay, so here I'm going to make a column for what marker I'm working with, like what part of the body. And then I'm going to make a column for its x coordinate in the horizontal direction, and a column for its y coordinate in the vertical direction. And my three markers that I had data for, where I had the position of my hip, position of my knee, and position of my ankle. And then here, under x, I'm just going to transcribe the x coordinate of each one of these markers. So for the hip, it was at an x position of 0. For the knee, that was at 9.5. And for the ankle, it was at 3.9. Then I'm going to do the same thing for my y coordinates. For the hip, it was 98 centimeters. For the knee, it was 45. And for the ankle, it was 3.5. Okay. So I've got my data in there. I just transcribed it from PowerPoint into Excel here. And the next thing I'm going to want to do is, and this is the tricky part, is implement that segment angle equation from PowerPoint into Microsoft Excel here. Okay. And so let's revisit that equation. It was my other PowerPoint here. Okay. So the general equation here for calculating theta seg, which is my symbol for the angle of a segment of the body, any particular segment, doesn't matter which one, is you take the difference in the vertical coordinates of the two joints that segment exists between, and you divide that difference by the difference in x coordinates between the two joints that segment exists between. You take the inverse tangent of that whole thing, and that gives you the angle of that segment. So for example, for like my thigh here, my thigh exists between my hip joint and my knee joint. Okay? The hip up here is the proximal joint. It's the joint that's closer to like the core of the body. And the knee is the distal joint. It's the joint that's further away from the core of the body. Okay? So in my equation up here, y prox, for example, would be the y coordinate of the proximal joint, which in this case would be the hip joint in the case of the knee here, or in the case of the upper leg here, in the case of the thigh. Y dist would be the y coordinate of the distal joint, which for my shank here, my distal joint is the knee, so y dist would be my vertical or my y coordinate of the knee joint there. Okay? So this is a place where you'll get to use your terms that you learn in anatomy and physiology classes, like proximal and distal, medial and lateral, stuff like that. Okay. Then same thing here on the numerator of this, or sorry, the denominator of this equation. X prox here would be the x coordinate of the proximal joint for that segment, and that would be the x coordinate of the hip in the case of my thigh. And x dist would be the x coordinate of the distal joint of that body segment, which would be the knee, so the distal joint of the knee in the case of my thigh segment here. Okay. So if that's all kind of hard to remember, then here we have it transcribed specifically just for the thigh. So my segment angle for my thigh would be take the vertical coordinate of the hip, subtract the vertical coordinate of the knee, divide that whole difference by the x coordinate for the hip minus the x coordinate for the knee, and then take the inverse tangent of that whole thing, and the result that you get out of that is the segment angle of the thigh. Okay? So let's go ahead and transcribe that here into Microsoft Excel. So I'm going to label my segment angles here, and I'm going to do it for the thigh. And to enter this thigh segment angle equation in Excel, I'm going to click on the cell that I want the result to appear in. I'm going to push the equals sign, which is telling Excel I'm going to enter a formula. And I'm going to type in atan, which is Excel's function for the inverse tangent here. And then inside atan there, I'm going to enter this argument here, this difference between the joint vertical coordinates divided by this difference between the joint horizontal coordinates. Okay. So I'm going to do a left bracket. And then I'm going to enter my difference in vertical coordinates, which is my hip vertical. So click on that cell. Minus my knee vertical. Click on that cell. And then I want to divide that by my difference in x coordinates. So x for the hip minus x for the knee. And then close my bracket out there with the right bracket to enter my whole argument there for that atan function. Now, those of you that know a little bit about math and about order of operations will say, you made a mistake here, and I did make a mistake here. I'm not quite done yet. What I want to do here is I want to take the difference in y coordinates and divide it by the difference in x coordinates. That's not going to happen if I do this operation here, if I enter this equation that I typed out here, because what this is going to do is it's going to take cell C2 and it's going to subtract from that cell C3 divided by B2, whatever that result is, and then it's going to subtract from whatever that whole result is, cell B3. Okay? That's not what I want. I want to take this difference and I want to divide it by this difference. Okay? To get it to do that, I have to pay attention to, if you think back to your math classes, order of operations, where when there's several operations all happening in this equation, it does the multiplication and the division first, and then it does the addition and the subtraction. Okay? So it's going to do this whole thing, and then it's going to subtract that from this, and then it's going to subtract this from that whole thing. To get it to not do that, to get it to take this difference and divide it by this difference, I've got to section those calculations off here with some additional brackets. I've got to bracket off that top difference, and then I've got to bracket off that bottom difference. Okay. So this is going to tell it, take this difference, keep it by itself, take this difference, keep it by itself, and then divide this one on the top by this one on the bottom. Okay? So that's how things work here in Excel and in general scientific computing. If you want to have a difference or an addition of two variables, divided or multiplied by a difference or addition of other two variables, you've got to section off those differences here with brackets. You've got to kind of use the brackets to get the difference by itself, and then you can do operations on it with addition and multiplication and stuff like that. Okay. So then when I hit enter here, then I get a number there. It's 1.4-ish or negative 1.4-ish. This is the angle of the thigh in radians. We more easily understand angles of things in terms of degrees, like a full circle is 360 degrees. A full circle is also 2 pi radians, which is about 6 radians, but we don't really visualize and understand rotations and angles with radians that well. We understand it better in degrees. So let's convert this to degrees. We do that by saying equals, and I want to take this value here, and I want to multiply those radians by 180 degrees, and then divide by the number pi. This is just how you convert in physics and in mechanics from radians to degrees. There's 180 degrees here in every 3.14 or 15 or every pi radians here. So to convert radians to degrees, I multiply the radians by 180 and I divide by pi. Okay. And this gives me my angle of the thigh in degrees instead of radians. Okay. It gave me a negative result there, which for reasons that we'll talk about in KNES 300, I'm not going to teach you about it today, but for reasons that you'll learn about in KNES 300, we don't want that negative angle there. When we get a negative angle for the segment angle, we want to add 180 to it. So to do that, I'm going to enter a third formula here on the right. I'm going to say equals my negative angle there plus 180 degrees. And that gives me about 100 degrees, which is the answer that I want there. Okay, now let's repeat this for calculating the shank segment angle. And this is going to be the inverse tangent of my difference in vertical coordinates of the two joints that comprise the shank. So the shank is between the knee and the ankle. So I'm going to take vertical knee minus vertical ankle. It's the most common tongue twister in biomechanics, ankle versus angle. Then I'm going to divide that vertical difference by the horizontal difference, the horizontal coordinate of the knee minus the horizontal coordinate of the ankle. Then bracket that off, bracket off the whole thing. And notice here again, I put my differences in my numerator, and in my denominator, I put them in brackets here so that Excel knows, hey, perform this subtraction here before you divide that difference by this difference down here. Okay, that's what those brackets are doing. It's sectioning off those subtractions so that they get performed before this division happens here. Okay, then you just enter it, and we get 1.4 something radians. And again, we want to convert that to degrees. So multiply by 180, divide by pi. And I get that my shank angle is 82 degrees. Okay. Then last thing I'm going to do is calculate my joint angles. And here in this problem, I was just asked to calculate the knee angle. And the knee angle, again, for reasons that you'll learn about in KNES 300, I'm not going to teach it to you today, but just accept it as fact for now. The knee angle is the segment angle of the shank minus the segment angle of the thigh. Okay. And that gives us negative 17.8 degrees, which should hopefully be the answer that I had here on the slide that I gave to the class. Yeah, negative 17.8. So don't worry there if like those mechanics aren't that familiar to you. If you're like, what's a segment angle? What's a joint angle? What's all this coordinate business? Those are the sort of things you learn in KNES 300, like why we do those calculations, why we do them that way, why they're meaningful, why they're important, why they exist in the first place in this field. What you should focus on here and what I just showed you is being able to do stuff like that in Microsoft Excel, like taking data here from a slide and transcribing it in an organized and understandable way into software like Excel. And also taking equations here from class and transcribing them into something like Microsoft Excel so that you can actually apply them and use them on actual data to actually perform calculations here and get like relevant outcome variables in biomechanics. Okay, the other common thing that you will use Microsoft Excel for in KNES 300 and in a lot of your classes is making graphs of data, making figures that you're going to include in like the lab reports that you will use in the lab section of class. And so let's look through an example of something like that. So I'm going to go back to my original sheet here in Excel. So often when you're making a graph, you'll be plotting like one variable versus another variable. Okay, and so here, for example, I have, and these were data actually measured for me some years ago, walking at a variety of speeds here on a treadmill. So the speed of walking, that's what this column A here is. And then my rate of metabolic energy expenditure, my watts or my energy expended per unit time while I was walking on the treadmill at that speed. These are measurements that you can take with what's called a metabolic cart, where somebody will be on a treadmill or on an exercise bike, and they'll wear like a mask-looking apparatus that then connects to a machine that's connected to a computer. From that, we can measure the rate at which you're consuming oxygen and the rate at which you are expelling carbon dioxide. And knowing those two rates, we can make some assumptions and can back out your metabolic rate, the rate at which you're consuming metabolic energy to power the contractions of your muscles while you're doing that exercise. So that's what these data are here. Speed of walking versus the metabolic rate while you're walking at those speeds. And there's quite a bit of data here. There's speeds from 0.5 meters per second up to 2.8 meters per second. So there's a little bit under 50 data points here, so quite a few data points. Metabolic rate, as you might imagine, scales with the mass of the person. Heavier people have, or just larger people in general, have more mass to support against gravity while they're walking or running or doing exercise that involves, bearing the weight of the body on your legs. And so they will have higher metabolic rates, not necessarily because they're like working harder or exercising harder, but just because they have more weight to support against gravity while they're doing things that involve bearing weight on their legs. So to account for that, we will often take metabolic or variables like metabolic rate here, and we will scale or divide them by the person's body mass. Okay? And so this is data that I've given you here for this person's body mass in kilograms. And so what we want to do here is we want to take this column of metabolic rate data, and we want to divide each one of those values by this person's body mass. So rather than having my metabolic rate in watts, in energy per unit time, I want to have it in watts per kg, or energy per unit time per unit body mass. It's a common way that we'll express the rate of energy expenditure in biomechanics and exercise physiology. So one way of doing this is I could say equals, and I could type in that number. Okay, the number that I want to scale here is 169.2, and then I want to divide it by this person's mass, which was 72 kilos, and that gives me my metabolic rate scaled by body mass there, 169 divided by 72. Okay. I could then repeat that for each of these other like 50-some variables. Okay, 174.24 divided by 72, 180 divided by 72. I would finish that eventually, right? But you can see I did 3 of them here, and it took me, I don't know, maybe 30 seconds, and I've still got about 50 to go there. It's going to take me a long, long time to type in all 50 of those. I might make a mistake. I might, type in 179.2 divided by 73 and not notice it and get the wrong answer up here. So that's not a great approach for doing this type of thing. A better way is, rather than transcribing the numbers by hand, just have Excel do that for you, right? So I can say equals, and then click on the cell that has the number that I want in it, and it'll transcribe whatever value's in that cell. And then I can divide that cell's value by clicking on this cell and dividing by its value. Okay? And again, I could also do that cell by cell here. I could say equals, click on this cell, divide it by that cell, equals, click on this cell, divide it by that cell. So that's a little bit faster than typing everything in by hand, but it's still, okay, this one, this one, this one, this one. Kind of mind-numbing, kind of boring, and still kind of error-prone, right? Like I could click on the wrong cell. I could say equals, oh, whoops, I clicked on this one and divided by that one. And I got a number here and it's wrong, but I may not necessarily notice it, or I may not know enough about these data to necessarily pick out on my own that that's wrong without somebody telling me it's wrong. So it's still not the best approach to use. Another way that you can do it, and this is a really handy thing in Excel, is if you have a column of numbers here, an uninterrupted column of numbers, and you want to enter right next to it a calculation involving those numbers, or just a repeated calculation that's repeatedly doing the same calculation in a column of cells here, where like you want to take everything in this column and divide it by some other number. An easy way to do that fast is you can just enter the equation in the first cell that you're working with. So just do equals this cell divided by that cell. And then see this little square here in the lower right corner of my cell here where it changes from like the white X to the black X there. If you then double click on that, it'll autofill that equation all the way down here. Now, it didn't do this quite right, and I made a mistake here on purpose to kind of show you a common mistake here in Excel and to demonstrate another thing you have to do in Excel to do these types of calculations. In this, let's just start over here. In this first cell here, I did equals cell B4 divided by cell B1. Okay. Now, another way that I could do this is I could copy this cell here, C4, and I could paste it into C5. Okay. And there it gave me a result that says hash div 0 exclamation point. This is Excel's warning or caution that it gives when it says, hey, you took a number and you divided it by 0, which mathematically is a bad thing. We don't want to divide by 0. That gives us funny results in math. We don't want to divide things by 0. That's not right, right? I said divide this number by that number. So I don't want you to divide 174 by 0. I want you to divide it by 72. So why didn't you listen to me? Why didn't Excel here divide by 72? Where's it getting 0 from? Notice here that in this first cell in C4, I told it take cell B4 and divide it by whatever's in cell B1. Okay? When I copy that formula and paste it down here, it took cell C4 and then repeated that calculation one cell below it in C5. Okay? So in C4, I told it, take the cell that's right next to you and divide it by the cell that's 1, 2, 3 cells above that cell. Okay? So unless I tell it otherwise, Excel assumes that's what I always want to do, right? So if I'm in C4 and I copy paste that into C5, it thinks, oh, you're in C4 and you wanted me to take the cell right next to that and divide that by whatever's 3 cells above it. Okay? So it assumes, unless I tell it otherwise, that I also want to do that here in cell C5. It says, okay, you want me to take the cell that's right next to C5 and divide it by whatever's 3 cells above C5. And what's 3 cells above C5? 1, 2, 3, nothing, right? This is empty, or it's 0 mathematically. There's nothing there. Okay? So what this is doing is it's taking cell B5, 174-ish, and dividing it by 0. Okay? So that's not what I want, right? In order to scale my metabolic rate here by body mass, what I want it to do is take those metabolic rates and always divide them by this cell. Okay, I want it to take this one and divide it by that cell and put it here. I want it to take this one and divide it by that cell and put it here. I want to take all of these and divide them by this cell and put them right next to it over there. So how do I get it to do that? And how do I get it to do that without just manually entering this in each cell, which will take me forever? To do that, I have to go back to my first instance of doing this calculation, and I have to modify it. I still always want it to grab the cell that's next to the one where I'm performing the calculation, because that's going to be changing. I don't always want to use 169 here. On the next one, I want to use 174. On the next one, I want to use 180, etc. So I'm going to leave B4 alone there. But in this calculation, I always want it to divide by cell B1. No matter what cell I'm working with here, no matter where I'm grabbing my metabolic rate data from, I want it to divide that rate by whatever's in cell B1. Okay? So to get Excel to do that, you put a $sign, shift 4, in front of B, and also a $sign in front of 1. Okay? What that's saying is when you use this formula that I'm soon going to copy paste down here, always go to cell B1. Okay? No matter what else is happening here, no matter what else is referenced, no matter where I paste this, always in this part of this equation go to cell B1. The reason you put $signs in front of both B and 1 instead of just a $sign in front of B or just a $sign in front of 1 is that I'm referencing this specific cell. Okay? There might be cases where like I always want to go to column B but want it to intelligently pick the row here. Okay? Or there might be cases where like I always want to go to row 1 but want it to intelligently pick the row there for B, or the column there for B. Okay? Neither of those is what I want here. I want it to always go to cell B1. So I'm going to tell it always go to row B, always go to column B and always go to row 1 and grab that value and divide whatever metabolic rate is right next to you by that specific value. Okay. So then I can enter that in my first cell here, and I can right-click on the bottom right corner there twice. And then it just fills all of that all the way down, all my calculations there instantly. And if I click on any one of these, let's just click on C42 here, you can see it's grabbing B42, the metabolic rate right next to it, and dividing it by cell B1, the mass of the person way up here. And we can double check this if we want. If we want to convince ourselves this is right, I can do 696.96 divided by 72, and I should get exactly 9.68 there. And I do. I got exactly 9.68 there. So by mastering those kind of little intricacies of Excel, this using $signs to force it to go to particular columns or rows or particular cells, and by like right-clicking or double-clicking on that little bottom right corner to like automatically fill in columns of calculations there, you can save yourself a heck of a lot of time in using software like this. Okay, another thing that you're going to do a lot of in Excel is we might want to make plots of these data, make graphs of these data. And how do we do that exactly? Well, we want to, let's suppose we want to make a graph here of speed versus the mass scaled metabolic rate. How do I do that? I'm going to highlight here my speeds. And then I don't know how you would do this on Windows necessarily, but on a Mac, you would hold down the Command key right next to the space bar. And while holding that down, you would highlight the other data that you want to graph here, the metabolic rate. So just highlight that speed column and highlight that metabolic rate column. Okay. And then I want to tell Excel to make a plot or make a graph of speed on the x-axis versus metabolic rate on the y-axis. To do that, I go to Insert and I go to Chart, and the type of chart that compares those types of data to each other, like one variable versus another variable in Excel here, is called an XY plot or a scatter plot. Okay, so this is going to take whatever I first highlighted there, whatever I highlighted on the left, speed, and put it on the x-axis, and then it's going to plot against that on the y-axis the second column of data that I highlighted there, the metabolic rate. Okay. So I'll click on that, and then a chart pops up here. Okay. Big important tip in Excel for not pissing off your TA and not pissing off your instructor. This is a really ugly chart, okay? Don't turn in that chart, okay? Don't just click scatter plot and call it good and paste it into the document. Spend some time making your charts look good, making them look nice. And so I'll give you a demonstration here of how to like play around with your chart and make it look nice and make it a nice, clean, easily understood plot of data. And this is something that's worth spending your time on. Spend some time not just making the chart and doing the calculations and having the right numbers, but spend some time on presentation. Spend some time making it look good, making it look nice, making it a pleasure to read for the person that's grading it, rather than a chore for them to get through it because it's ugly and difficult to understand. Okay? So what can I do here to kind of pretty up my charts? Well, in science, we don't put titles on charts. So just get rid of that chart title. Click on it and just delete it. Okay? In science, we do put labels on axes. We do label what's shown on the x-axis and what's shown on the y-axis. And how do I do that? Well, I go to chart design here. And over on the left, I do add chart element. And I go to axis titles. And I say add a primary horizontal. And then I go back, go to axis titles and say add a primary vertical. Okay. And that added here my axis title on the horizontal axis and my axis title on the vertical axis. Okay, and then let's put in some titles for those. So on the x-axis was speed in meters per second. And on the y-axis was metabolic rate in watts per kg. Okay. And then let's highlight those a little bit. Let's have those stand out so we can make sure that it's seen what they are. So I'm going to make them bold here, Command B and Command B. Okay. I don't like having these dots here. I think that looks kind of ugly. So I'm going to change it to a line. And how do I do that? Well, I can click on it. And I can go to Format. And I can do Format Pane here. And then clear over here on the left, I can kind of change what my data look like. So I want to have a line here that connects my data. And it's going to just be a blue line there, and let's make it a little bit thicker. Let's make it 2.5. And then I don't want these markers. So I'm going to go to Marker Options and just get rid of those markers. Okay. So then I've got a line there showing my data, metabolic rate versus the speed of walking. Now, let's suppose here I also wanted to put another type of data on here. Metabolic rate is one way that we quantify kind of the energy expenditure, the efficiency or economy of movement in biomechanics and exercise physiology. Another way that we quantify it is by the metabolic cost. Metabolic cost, which is, rather than being the energy per unit time, is the energy per unit distance. And this ends up having units of joules per meter per kilogram. How do I calculate metabolic cost? Again, don't worry about why this is the case. That's outside the scope of this lecture. These are things that you'll learn in classes. But metabolic cost equals the metabolic rate divided by the speed that you're traveling at. Okay? That converts my energy expenditure from a basis of per unit time to a basis of per unit distance. Okay? So then I'm going to hit return. And I'm going to move my chart out of the way here so I can see everything. And then again, I want to do this for all of my cells here. I want it to say, okay, take this metabolic rate and divide it by this speed at which I consumed energy at that rate. Okay, so for each one of my cells, I want it to say, take this metabolic rate and divide it by this speed over here. Okay. So I already did that in my first cell. And since there's no particular cell here like mass that I need it to reference, it's always just taking this one and referencing it to whatever's two cells next to that cell. I can just double click my right corner here and it populates it all the way down there. And then let's suppose I wanted to make another graph of those data. And I could highlight speed here. And I could highlight metabolic cost. And then I can make another chart there, insert chart, scatter. And then I've got a second chart there. And then here I could start over with, deleting my title and adding axis labels and changing the appearance of the shapes and the lines of the data and all of these things. Okay. What if I wanted both of these plots, or both of these data, on the same plot? It is possible to add a time series here. You can do right click and do select data, and then I can add a new set of data there. And then I can go here, X values, and select these speeds, and then I could go here and do Y values and select those speeds. It's sometimes easier to just delete your chart and start over and say, okay, I'm gonna plot versus speed these two columns of data. So just select all the speeds and select both columns of data there, the metabolic rate, energy per unit time, and the metabolic cost, energy per unit distance. I can then go to insert and do a chart and do a scatter chart. And there it plotted both sets of my data, my metabolic rate in blue and my metabolic cost in orange. Okay. So I can delete chart title there, just like I did last time. I can go to add elements and add my horizontal title and add my vertical title. And my horizontal title is still speed, meters per second. And let's make that bold. My vertical title, I'm now just going to call it energy expenditure rate. And I'm not going to give it any units because the units depend on which graph I'm looking at here. Notice here that in my legend that Excel stuck down there, it doesn't know which one's which. It doesn't know on its own, like, oh, the blue one's metabolic rate and the orange one's metabolic cost. So I got to go in and tell it which one's metabolic rate, which one's metabolic cost. I can do that by right-clicking on the middle, and I go to select data, and then I can name these things. I can click on series 1, and name is blank there. And I can say, well, that's not series 1, that's going to be metabolic rate in watts per kg. And I can click on series 2, and I can say that's not just series 2, that's metabolic cost in joules per meter per kg. And then I can click OK. And then notice here in my legend, it's now changed the labels in the legend to being those names of the actual variables that I wanted to have there. I don't like having my legend outside the chart here. That looks weird, so I can drag it in there. And then now I've got this big ugly white space there that's kind of wasted, so I can take my space there for the data and drag it down there and clean it up a little bit. Make it look a little nicer. My legend here I think looks kind of funky. I don't really like that, so I'm going to make it a little flatter, and make it a little taller, and make it a little narrower, and maybe a little bit flatter. And then I don't like it kind of being transparent here. That looks weird, so I can click on it, and I can go to its appearance here. And for border, I'm going to give it just kind of a light gray border, and for fill, I'm just going to fill it with a white color there so that it doesn't, get transparent. And then I didn't like these symbols, so I'm going to go and make them lines instead of markers. And same thing here for the orange guy, no markers, and give it a line. And it picked the same color there, so I'm going to make it, I don't know, I like orange. And let's make these a little thicker. And this one too, make it a little thicker. So just some steps there that you guys can do when you're making charts and graphing your data to make it look a little bit more presentable, make it look nice, make it easy to understand for a reader and for the person grading it. Good skills to work on developing now before you get into these core classes in kinesiology that'll benefit you a little bit later on, so that you won't have to be trying to learn biomechanics at the same time that you're learning how to make charts in Microsoft Excel. That can seem a little bit overwhelming. So being able to do things like this fairly easily ahead of time, like being able to transcribe an equation from a book or from a slide and actually do calculations with it in Microsoft Excel, or being able to plot data and do calculations and manipulations of data and making plots that not just plot the data, but plot the data in an attractive way and an easily understood way. Good skills to work on now, and good things that are going to help you if you know how to do them already before you get into a class like KNES 300. Okay, that's all I have for that, and I hope this was helpful in general, and I hope I will see you guys someday in KNES 300. So good luck, and we will catch you later.